Hello world, my name is Kshitij, this is the coding tree, and today we're talking about conditions and Boolean statements. Let's start with conditions. To begin, let's write a simple program that just takes input from the user and then prints hello, comma, space, the input. So if I was to provide my own name, it would print hello, Kshitij. The code that you see right now performs that. It just takes input from the user, stores it in a variable called x, and then prints that variable back out with hello, comma, space in front of it. Notice that there is a comma after the end quotation mark, which basically denotes a concatenation, where you take one string, you take another string, and then you combine them. That's how you're able to print hello, comma, space, name, because we're able to combine those two strings using that comma in between, which is concatenation. Well, this works, obviously. It takes input from the user and then prints out hello plus the input. Let's imagine the previous program as a login system, where the user inputs a username, and if that username is equal to the one that we've already pre-stored, then we greet the user. Otherwise, we just print out, let's say, imposter to the screen. How would we go about doing that, though? Well, now we can introduce the notion of if statements. Statements that will allow you to make decisions on whether or not to run certain bits of code. If statements can often also be followed up with else statements, where if the if condition is not met, you do something else and run some other piece of code. You can quite literally imagine this logic in English. If something is true, do something. Else, do something else. It's literally all that it is, but if statements will allow us to start writing more powerful and dynamic code. So now let's go back to the login example. So let's say that the name that we want to store and authorize is Bobby. So we can just create a variable called name and store Bobby in name. Then we can obviously get input through x, and then we can check if x is equal to name. How do we go about doing this? Well, that's where we introduce our new bit of syntax. If x is equal sign name. Why do we use two equal signs? We always used one before, right? Well, that's precisely why we use two equal signs. One equal sign indicates an assignment, where you're assigning some bit of data to a variable. Do equal signs means that you're checking if two things are equal to each other. If they are, that equal sign returns true, which is a bool. Otherwise, it returns false, which is also a bool. Recall that booleans are only trues and falses, or zeros and ones. And that's how our if statement decides whether to run the code or not. If true, then run. If false, then don't run. So going back to the example, if we input Bobby, then yeah, it's true, so we print hello Bobby. Otherwise, if we input Kshitij, we see that it's not true anymore, and it prints the else statement. I guess I'm an imposter now. You'll also notice that at the very end of the if statements, and also at the end of the else statement, there's a colon. Why? Well, that colon and the following indented lines indicate that those lines are a part of the if statement. So since else isn't indented, per se, it's not a part of the if statement, but the line right above it is, because it's indented and it follows the colon. Same with the statement following else. It's indented and it has a colon, the line above it has a colon, which would mean that it is a part of the else statement. So just as a quick rundown of our code takes input from the user, stores it in a variable called x, it creates a second variable called a name and stores Bobby in it. It checks if name is equal to x. If it is, it prints out hello, comma, x, or input from the user. If it isn't, then it prints imposter. Boom, we have some working code, but you may notice that there is a slight problem with it. If the user also goes by Bob and says that his name is Bob instead of Bobby, which it is, our program would still just assume that he's an imposter. Obviously, we don't want that, but how do we fix it? Well, it's actually not that bad, but here we're going to introduce another concept called Boolean Operators. There we can combine two Boolean statements and get a result. So first, let's create a second variable called name_short. Now in Python, it's just simple convention to have an underscore between two words in a variable name, but you can also just capitalize the second letter, which is convention in some other languages. We'll set name_short equal to Bob. Now we can check if x is equal to name, or if x is equal to name_short. And we can do this quite literally in English. If x is equal to name, or if x is equal to name_short. It works both ways. So that's it. We add the or, and we can check if either one of those is true. The way that Boolean operator works is that if either the first statement or the second statement is true, then it returns true. Now our program works with both Bob and Bobby, because we can just use the or statement to check if either one of them is true. Just like or, there are a few other Boolean operators that it's crucial to know. First, let's start with and. Now all this one does is check if both sides are true. The logic follows in English. If x is true and y is true, then run this code. If one of them is false, then both aren't true, so we don't run the code. That's how and statements work. They're pretty simple, and they have their own uses. Next, we can look at not. All the not does is flip the value. So let's say we wanted to write a program that authorized anybody who isn't Bobby. Well, we can simply do that by adding a not to the beginning of the first if statement. So if we passed Bobby into that, well, x is equal to Bobby, which means that would be true. But remember, we added the not statement at the very beginning, which makes that false, and thus it prints the else code, which is imposter. But if we input a different name, let's say Catherine, then that would be true, because Catherine is not equal to Bobby. But remember that the not statement flips that to a true, which means that that would work, and so would literally anything else except for the name Bobby. As our final program for today's video, we can go over comparison. We don't always want to only check if two things are equal to one another. We also want to check if one thing is greater than, less than. For this one, you're going to pause the video and see if you can figure it out for yourself first, and then we'll go over it together. So all you're going to write is a simple program. It takes input from the user, and then it checks if that input is a positive number, a negative number, or if it's 0. But before you pause the video, let me give you some helpful hints. Comparison in Python is pretty easy. You can think of it the same way as you would in math. We can use the greater than sign or the less than sign. If we wanted to do, let's say, less than or equal to for some reason, we can just do a less than sign and then add an equal to at the end, which would be less than or equal to. The same concept for greater than or equal to. And finally, if you want to check for more than just one condition, so if you want to say if something is true, else if something is true, and then else, you can just do a statement called elif, short for else if, which you follow with a condition, and if that condition is true, it prints that code. Some general logic you can follow incorporating these ideas: if something is true, do something, else if something is true, do something else, and else, do something else entirely. That's it for now. Pause the video and come back in a few minutes after you've written this program, and we can go over it and see if there's any changes that are needed to be made. And the answer is up on the screen now. Did you get it right? Well, let's see. First, we obviously store input from the user in a variable called x. Then we check if x is greater than 0. If it is, then the x is positive, so we print positive. Else, if x is less than 0, then obviously x is negative, so we print negative. Else, x has to be 0, so we print 0. Boom. That's the logic behind a decently complicated program for starting out, and I hope you actually got it. If you didn't, take a moment to understand how the code works now. That's all for now, but understand that today we introduced an extremely powerful tool that will allow you to write even more dynamic code. This is an important step in being able to write more powerful, better, and bigger code. That's all for now, folks. I hope you enjoyed and I hope you learned something. If you did, make sure to drop a like, and if you want to continue your computer science journey, hit the subscribe button to stick around. If you want to go to the next video in the series, just click here and go to that.